A rectangular package sent by the U.S. Postal Service has a maximum combined length and girth of 108 inches. The girth of the package is determined by adding the perimeter of the cross-section of the package. Draw a picture that models the information above. The length of the base is represented by Y. The width and the height is represented by X. The girth is this cross-section. You're going to add up all of these 4 lengths. We can see this length is X, X and X. We can see the height is X, X and X. So if I came up with the formula here, it says 108 equals the length, which is Y, plus the girth, which is all the way around the cross-section. That's X plus X plus X plus X. There's 4 X's. We're going to come back to that formula in a little bit. So I've drawn the picture. We know that this is a length of Y. Again, this is X. And now we're actually going to come up with that formula. Express the length of the package in terms of X. So I went through and created this formula based on the given information. The maximum combined length plus girth, this is length plus the girth, is 108. Here's my length, and then here's the girth. I add up all the way around the cross sections, and that's how I came up with 4x. We want to express the length, which is y. That means solve for y in terms of x. So subtract 4x, subtract 4x. 108 subtract 4x equals y. So, how do we express the volume? The volume of this shape is length times width times height. Now, I'm going to replace those with what I know. We know that this length is represented by y. We know the width is represented by x, and we know the height is represented by x. When it says express the volume as a function, I need to see this on the left. That's required. On the right, I must only see the variable x being used. So that means I need to take out the y. Now, I know what y is equivalent to. Y is equivalent to 108 subtract 4x. 108 subtract 4x. Next up, please do second plus 712 on your calculator. Second plus 712 on your calculator. Let's come up with the domain. After you've cleared your calculator, let's type this in. 108 subtract 4x. And you could write x squared at this point, or you could just do xx. Now, when we think of the domain, remember, x represents the length of the width and of the height, which are equivalent. I know those lengths can never be negative. 0 actually won't even occur, or we wouldn't even have the shape of this box. So I'm putting 0 down, but I know it has to be greater than that. Now, how do I know what to do with the x maximum? We're just going to approximate. Let's all try 25 and do zoom fit. 25 with zoom fit. I can see 25 is close, but I can't exactly see what the 0 is. Let's lengthen that and go out to, let's try 40 and do zoom fit. 40 is fine. 40 is fine. So when I determine what the domain is, I need to start by going, what will be these x-intercepts? I believe one of them is going to be 0, and I can clarify that is true. 0 is one of them. I know it has to be greater than 0. It can't actually be equal, or we would not have the shape of this rectangular box. And now I need to find the next one. Second, calculate. Let's find that 0. So I'm going to do 15, and then I know this is 40. Let's go somewhere really close to that. So in between, I press enter, and 27. So it can go all the way out to 27 and include 27, but it cannot include 0. A couple more questions here. Determine the volume when the length. So remember, my length is y. Determine the volume when the length of the package is 80. So I need to put this into numbers for me. Okay, length is y. So when y is 80, and we know that the volume, determine the volume. I don't know the volume, and the length is 80. Okay, so I have a couple different ways that we could do this. One is, I remember that I had that formula that was created early on, and I'm going to write that formula down. It was 108 minus 4x equals y. So when y is 80, let's determine what x is. So I'm going to start by subtracting 108 on your calculator. Please take 80, subtract 108. After you have that value, please go ahead and divide by negative 4. And we end up with x equals what? 7. Okay. Now, that means that this would be 7, this would be 7, and this would be 80. Now, I want to go over two different ways that you can identify what the volume is. One is some of you may go, okay, well, I know that volume is length times width times height, and we can multiply those in any order to achieve the answer. And so we have 39, 20, again, this is inches cubed for the volume. That would be fine. Others go, okay, I know when x equals 7, I can use this graph and go second calculate value, type in 7, and we get the exact same answer. How do we determine the maximum volume? I need to know what this is. Now, for me right now, I've created right now a window that goes from 0 to 40. Keep that in mind. I want to know what is this maximum. With me, please go second, calculate maximum. I'm choosing a number somewhere down here like 15. Now this goes out to 40. I'm going to choose a value over here like 35 and pressing enter. So what is the maximum volume? The maximum volume is 11,664 inches cubed. We're going to get to the next piece. It's going to say, when does that happen? So what will be the dimensions when that happens? I'm keeping this present. Those dimensions will happen when x equals 18. So I'm going to come over here and write 18 and 18. I don't know what the length is. Well, I want to solve for y. I know that this is the maximum volume. I know this is the maximum volume, and it happens when x, which is the width and the height, is 18. A couple different ways we maybe could do it, but I believe that this is possibly the easiest, as I'm going to write down this formula. 108 minus 4x equals y. So again, I want to know y when x equals 18. On your calculator, please take 108, subtract 4 times 18. 108, subtract 4 times 18, and we get an answer of 36. So what are the dimensions and how do we write them? The dimensions do not have to be in a specific order. We just need to have the three numbers. So 36 by 18 by 18. Or, again, any order as long as you have two of those being 18 and one being 36.